So I'm sure you all know lemurs are a group of primates that exist only in Madagascar. Madagascar is this big island off the southeast coast of Africa, and it's been isolated for an incredibly long time. As part of the Gondwanan supercontinent, which split up, Madagascar split off 160 million years ago, which is a ridiculous amount of time. It's 100 million years before the extinction of the dinosaurs. So everything that's on Madagascar has lived there in isolation for extraordinary amounts of time and has evolved to become uniquely Malagasy species. So almost everything that lives there exists nowhere else on Earth. So there are 11,000, 12,000 species of plant, 85% of them are only in Madagascar. 99% of amphibians, 92% of the reptiles, even the birds, which obviously are great dispersers, half of all bird species on Madagascar exist nowhere else. And when it comes to the mammals, 100% of non-flying mammals are endemic to the island. And they include the lemurs, of course, which is what we're here for. So what are lemurs? They're a group of primates. This is a phylogenetic tree of the living primates. We have at the top there the old world primates, then the apes. In the middle of the apes there, I don't know if you can see, but that's the genus Homo, that's us in case you think we're anything special. And then here are the lemurs. Now, you'll often hear in the media, you'll hear them talk about the lemur. But the lemurs aren't one species, they're in fact incredibly diverse. At the latest count, there are 112 different species of lemur, and they're diverse not just at the species level, but at higher taxonomic levels. So there are 15 different genera, that's 20% of all primate genera on Earth, and they're in 5 different families, so that's a third of all primate families. So I just want to give you a bit of a tour of these families so we get a grasp of the diversity of living lemurs today. The main family of diurnal species is the true lemurs, the Lemuridae, which includes the ringtail lemur, red-bellied lemur, white-fronted lemur, I like this one. The several species of bamboo lemur, which have evolved to be able to digest the extraordinary amounts of cyanide in bamboo. This is the greater bamboo lemur, which was thought extinct for a long time. And there are ruffed lemurs. The second major family is the Indriidae, which includes the largest species, the Indri, the largest living species, which has this amazing song. Now, I'm a terrible technophobe, but I'm going to try and play the song. Sorry, I did warn you. Bob, where's my slideshow gone?
It's up there somewhere.
This one, okay.
It's going to take a lot of editing if it is there.
Sorry, everyone.
Leave it in.
Okay, so that was the sound of the Indri, which is just wonderful. Some of my students here have heard that in the wild. To me, it sounds like whale song played through a kazoo. The other big genus in the Indriidae family are the shivak, which are just wonderful. This is the Veros shivak, there's Cockerel's shivak, Diadem shivak, and Golden Crown shivak. So that's 4 out of the 11 shivak species. There's also one nocturnal genus within the Indri family, the woolly lemurs, or Avahi. The third big family is the Caragaleidae, the dwarf lemur family, which includes the world's only hibernating primate, the fat-tailed dwarf lemur. This is what might be an undescribed species of dwarf lemur that my wife and I discovered when we were on holiday on this little island off the north of Madagascar. So there are some researchers looking at the genetics of that at the minute, and it might be a new species. There are mouse lemurs. These are the smallest primates on the planet. Many, many species of mouse lemur, as we'll see. This is a giant dwarf lemur. I love the idea of a giant dwarf. There's the lepidlemur family, or the sportive lemurs. This is Randrine Sulu's sportive lemur, and the white-footed sportive lemur. And then the last family is the ii. It's the only living member of its family, and it's a famously bizarre animal. Stephen Fry memorably described it as if someone had tried to turn a cat into a bat. But that's just the living species of lemur, and it's only a partial picture, because until very recently there was a huge additional diversity of species that have gone recently extinct since people arrived on the island of Madagascar. So there were 17 additional species that have gone extinct as far as we know, and they're in 8 different genera and 3 different families. Each of those were bigger than the injury, so the biggest species went extinct first. This is the skull of a sloth lemur. And the amazing thing about these extinct species is how recently they existed. So the youngest subfossil bones are just 500 years old. These things existed until Europeans arrived in Madagascar. And when we think of extinct megafauna, we tend to think of them as the ancestors of the living fauna, but these were not the ancestors. These were the contemporaries of the living fauna. They're very much a part of the living fauna. They just happen to be extinct. And the threats that drove the extinction of these species continue today. So the main one is deforestation, driven by shifting cultivation, the use of fire to clear forests. And it's still a huge problem today. So this is the protected area where I spent many years working. Didn't do a very good job, obviously. And deforestation is a particular problem because almost all of Madagascar's endemic biodiversity is forest dependent. So it was probably largely forested when people first arrived there a couple of thousand years ago. Now less than 15% of the island is covered by forests, and half of that has been lost in the last 60 years. To put that into context, it took Europe 6,000 years to lose half of its forests. And what's particularly worrying is that there aren't any big blocks of forests anymore. So half of all forest is within 100 meters of the edge. And if you know anything about ecology, edge effects are a big issue. So deforestation is a major problem. There's also forest degradation. So rather than the outright clearance of forest, just the selective logging of trees within it, because most Malagasy people, 90% of households in Madagascar, don't have electricity or gas to cook with, so they cook every day on charcoal produced from natural forests. So when we talk about conservation and we focus on the need for conservation for biodiversity, in Madagascar it's very much a humanitarian issue too. When these forests are gone, nobody will be able to cook their rice. There's also hunting. Lots of Malagasy people that live in rural areas depend on bushmeat for dietary protein. Thankfully, until recently, there hadn't been any trade in bushmeat, but there's increasing evidence that is now starting, and it's largely linked to increasing numbers of Chinese investors and tourists visiting Madagascar, demanding lemur meat. And then there's also a pet trade linked to tourism. Tourists want their hotels to have lemurs in cages. This picture was taken on the beach of a sleepy fishing village near where I used to live. It's a tiny village, maybe 500 people, but every year there's a big cruise ship parks offshore, disgorges 2,000 South Africans onto the beach. So all the fishermen go into the forest to try and catch baby lemurs so they can make a little bit of money with tourists wanting their photos taken. So there's all these issues, and as a result, lemurs are highly, highly threatened, and they require a lot of conservation attention. Now, fortunately, Madagascar is widely considered the world's #1 conservation priority, and that means it has received a lot of conservation attention. And there have been some fantastic successes. So our main conservation tool globally is protected areas, and Madagascar has managed to quadruple the extent of its protected areas since 2003, which is fantastic. And many of those sites are co-managed by the local communities that live around them, so there's been a lot of work gone into empowering rural communities to manage their resources more sustainably. On top of that, there's been specific actions directed at lemurs, being the flagships of Malagasy conservation. And these efforts culminated in this document, the Lemur Conservation Strategy, which was published a few years ago. When we're planning how to conserve lemurs, there's a number of key questions that we need to ask ourselves. How many species of lemur are there? How threatened are they? Of all the places we could invest in conservation, which are the most important ones where we should focus our efforts? And having identified those priority sites, what should we do there? And you'd think these are relatively simple questions that conservation science can provide straightforward answers to. But it turns out that it's a bit more complex than that. So how many species of lemur are there? You've heard me say there are 112, but that's not always been the case. In 1994, there were 32 species of lemur. So yeah, it's almost quadrupled since then. And if we look at the 4-year gap from 2005 to 2008, there was a 60% increase in the number of lemur species just in 4 years. To take, for example, the mouse lemurs, in 1998, when I first went to work in Madagascar, there were 2 species of mouse lemur, one in the west, one in the east. By 2016, there were 24 species of mouse lemur, and others that have been put forward as candidate species, they just haven't been formally described yet. So when you hear in the media about new species being described, we tend to assume we're talking about scientists going into unexplored forests and finding completely new forms, novel animals that are clearly different, and describing those as new species. But that's not really the case in Madagascar, and in fact there's a lot of disagreement about this amazing fluorescence of species. Does it represent a real diversity, but cryptic diversity, or is it some form of taxonomic inflation? And if we're to understand that, we need to understand what are the processes that have been driving the increase in numbers of lemurs. The first one is the application of molecular techniques. In the past, we just used morphology, what an animal looked like. Once we started to use DNA and look at the genetics of cryptic animals, so animals that looked very similar, the 24 species of mouse lemur, they're identical. If you look at them, you couldn't tell one from the other. But if you look at their genetics, some of them are quite different. So obviously the use of these molecular techniques led to an increase. But the main driver of that increase has been the use of the phylogenetic species concept. Now you'd think it's straightforward what a species is, but in fact there are dozens of different species concepts. And the one we're most familiar with is Ernst Mayer's biological species concept. This is what we learn in A-level biology. And it basically says that if 2 populations can interbreed and produce fertile offspring, then they are the same species. What the phylogenetic species concept says is that any 2 populations that are diagnosable on any criterion can be considered independent species. And this has attracted a lot of criticism from a number of people, primarily the evolutionary anthropologist Ian Tattersall at the American Museum of Natural History. Because Ian says that to use a species name is to put forward a hypothesis that these 2 populations are embarking on separate evolutionary trajectories. And of course, as with any hypothesis, you need to present evidence to confirm it. And there's all sorts of different lines of evidence you could use: morphology, genetics, ecology, behaviour. You can use differences in vocalizations, whatever. But the more different evidence you use, the firmer your hypothesis is that these 2 separate populations are actually splitting. They're different species. What the phylogenetic species concept says is that if you can spot any difference between them at all, then they're separate species. So if you applied that to domestic dogs, for example, you would say a Doberman and an Alsatian are completely different species, even though using the biological species concept, you'd say they're the same because they can produce fertile offspring. So Ian Tattersall has looked at the robustness of the evidence presented for these 112 lemur species, and he thinks that actually 47 of them are robustly genuine good species. So 60 odd don't have sufficient evidence to say they are actually species. So why is that important? Well, for a start, it's different to what other groups of taxonomists are doing. So if we look at the Eupleridae, which is an endemic family of mongoose-like carnivorans in Madagascar, they're going in the opposite direction. That's the Fusa, by the way, the famous one from the movies. Until a couple of years ago, there were 10 species in the Eupleridae family. That's now down to 8, because some species that were considered species are now considered just subspecies, even though they look different. But because those taxonomists are not using the phylogenetic species concept, they decided they're subspecies. So we've got different groups using different concepts and coming up with different outcomes. Using the phylogenetic species concept tends to results in a 50% increase in the number of species over the use of the biological species concept. And of course, if you're splitting a widespread species into several species, then each of those species is obviously going to have a smaller distribution and going to be much rarer than the original ones you split it from. So it leads to this increase in range-restricted threatened species, which obviously adds to the complexity and the costs of conserving all species. It also, by splitting species, saying they're different, it prevents us using certain conservation methods like genetic rescue, translocations, or re-establishing gene flow between separate populations, which are important conservation methods for increasing the viability of small populations. But if suddenly you're saying every small population is a different species, you can't do that anymore. But perhaps the biggest issue is that by placing all these different groups on an equal footing, saying they're all species, you risk misallocating funds, and we don't have a lot of funds, but you risk misallocating them to evolutionary ephemera rather than genuinely divergent evolutionary lineages. So it's a real problem. Second big question I want to address is how threatened lemurs are. And we have a wonderful, widely applied and objective method of assessing extinction risk, the IUCN Red List, which has a firm set of criteria for determining how close a species is to extinction. The lemurs as a whole have undergone 3 Red List assessments in the last 12 years, and they've all produced increasingly worrying results, and they've attracted a lot of press attention. These are newspaper headlines from following last year's assessment. Lemurs are the most endangered mammals in the world. Nearly every species of lemur is going extinct. But when we look at the data, there's been this extraordinary growth in the number of threatened species between assessments. The 2018 assessment hasn't been published yet, so I can't use that. But looking between 2008 and 2012, in 2008, 40% of species were in the 3 threat categories: critically endangered, and vulnerable. And half the species were data deficient. We don't know enough about them to be able to say how threatened they are. By 2012, that had jumped to 90% of species are threatened. Very headline grabbing. And as you can see, the number of data deficient species has gone down hugely. So largely, this trend can be explained by data deficient species being put into threatened categories, whether new data was made available or not. And of course, it's partly to do with the splitting of species into multiple smaller species. But for a number of species, they made sort of inexplicable jumps in threat status. There were 8 species that were elevated from near threatened, i.e. not threatened, to endangered between 2008 and 2012. And for some of them, the evidence just doesn't add up that they are endangered. And I want to talk about 2 of them in particular because they're very well-known and charismatic species, the ring-tailed lemur and the eye. So ring-tailed lemur has always been considered one of the most widespread and common species of lemur. So when 2 papers came out in the last few years saying that they'd undergone these massive population crashes, it caused a big storm in Madagascar, and lots of people who know ring-tailed lemurs were really perplexed. So there are 2 groups of researchers who tried to estimate how many ring-tailed lemurs there are. And what they did, they used the literature and they did some rapid assessment at some sites to try and do 2 things. Find out how many different sites ring-tailed lemurs still exist in, and then estimate the populations at each of those sites. And they came up with remarkably similar results. There's about 34 sites where ring-tailed lemurs still exist, and there's about 2,000 ring-tailed lemurs left. That was a big issue because we thought there were tens and tens of thousands. So there were big headlines. Madagascar's lemurs close to extinction. 95% population crash. But these papers invited quite a lot of ridicule amongst people that know about surveying lemurs because they're hugely methodologically flawed. So some colleagues and I published a rebuttal to these papers highlighting the methodological flaws. We published this in the International Journal of Primatology. And there were 2 main flaws. The first was they didn't sample all the known populations. So they said, okay, we've searched through all the literature and we found that there were ringtail lemurs in 34 sites. My mate Barry and I sat down for a few hours and we came up with 45 other sites where we personally, between the two of us, had observed ringtail lemurs, or we knew that they existed because they were in the literature, but in literature that these authors hadn't found. So, with hardly any effort at all, we more than doubled the number of known sites. The other big issue was that for each of the sites that they said there were ringtail lemurs, they didn't do proper sampling at each of those sites. So one of the papers talked about the population at Simon-Pietzschutz National Park, which is down here. They went to 2 sites in Simon-Pietzschutz. They counted 67 lemurs at one of them and 40 at the others, and they said the population of lemurs in Simon-Pietzschutz is 107. Simon-Pietzschutz is massive. It's 250,000 hectares. It's the size of Dorset or Derbyshire. It's 2/3 the size of Kent. So what they've done was the equivalent of going to 2 sites in Derbyshire, counting 107 squirrels, and saying the total squirrel population of Derbyshire is 107. You don't need to have done my module in survey and monitoring techniques to know that there are some issues with that. The second species I want to highlight is the ii, which is quite well known because it's such a weird looking creature. There are some ethnicities find it a harbinger of evil, and they kill it when they see it, and they hang it up on signs at the edge of the village to ward off other evil spirits. But actually this is a really rare thing. Only a couple of ethnicities do it, and it rarely happens. But anyway, the ii is nocturnal. It's incredibly hard to see. You never ever see iis. They're so they're not rare, but they're so sort of shy that in the 1930s it was thought to be extinct. When Gerald Durrell went to Madagascar in the 80s to collect animals for his zoo, he wanted to collect iis because they were thought to be on the edge of extinction. Since then, everywhere where people have looked, they found iis. It exists in at least 32 protected areas. It is far more widespread than any other lemur species. It's also highly adaptable. It's one of the few lemur species that can exist outside forests. It lives in fruit plantations. Nevertheless, in 1986 it was classified as endangered. But given that new sites, new ii populations were turning up all the time, lots of doubt was placed on its assessment as endangered because they're everywhere. So in 2008 it was downgraded to near threatened. And yet, inexplicably, in 2012, it was back up to endangered, despite there being no new evidence of any declines, beyond declines associated with the deforestation that everyone suffers from. So, it occurs in 32 protected areas. It's a well-protected species. It doesn't make sense that it's classified as endangered. So if there is this issue of what we term red list inflation, if the threat status of at least some lemur species is more elevated than it should be, then why might that be happening? And thinking about this, it got me thinking about the scientific method. So according to philosopher of science Karl Popper, the scientific method depends on falsification. You develop your hypothesis and then you try to prove it wrong. And when thinking about those 2 papers on ringtail lemur declines, I just don't think that the authors used this approach. It just seems clear the only way they could find the results they found was that they developed a hypothesis that ringtail lemurs are suffering massive declines, and then they tried to prove it right. The first step of their research was to try to find as many ringtail lemurs as possible, as many ringtail lemur populations as possible. Now, if I was doing that, the first thing I'd do is I'd write to everyone I could think of and say, do you know any ringtail lemur populations? But they didn't put out a call for information. Even worse is, when we published our rebuttal saying there are these at least 45 extra sites, they rejected that evidence. They said, no, those observations are unpublished. They don't count. We're going to stick to our guns. There are only 34 ringtail lemur populations. Now you'd think these people would be overjoyed to find that ringtail lemurs are not half as threatened as we thought they were, but in fact they weren't. They rejected the evidence we presented. So why would that happen? And it got me thinking about our incentives as researchers. So researchers and conservationists, we compete for funds in what's been called a global bazaar economy. And there are all these funding sources like IUCN Save Our Species Fund, like the Mohammed bin Zayed Species Conservation Fund, that are only available if your species is endangered. They're only for species classified as threatened on the IUCN Red List. So we can see why there might be incentives to produce results saying that your species is endangered. And it made me realise that actually there might be conflicts of interest in conservation. When those authors published their papers, they signed a declaration saying that we have no conflict of interest. But two of those authors are lifelong ring-tailed lemur researchers. They do research on ring-tailed lemur behaviour and evolution. Obviously, if their species is now endangered and gets lots of press, it's easier to attract funding. Two of the other researchers run an NGO dedicated to the conservation of ring-tailed lemurs. Now they have access to these funds, which they didn't before. Perhaps these conflicts of interest are more rife in conservation science than we might think. So why does it matter if we have this red list inflation? Well, the first reason is that the red list is an objective prioritisation tool. It's the best tool we have for objectively measuring extinction risk and making decisions on the basis of that. But it only works if it's consistently applied. So if researchers in Madagascar are applying the red list criteria in one way, but researchers in Brazil are doing it another way, then we really have no way of knowing whether Brazilian primates or Malagasy primates are actually more threatened and more deserving of our attention. There's the risk of crying wolf. I'm sure you all know Aesop's fable, so I needn't go into that. But for me, one of the most important problems with this is that we risk losing the trust that the public places in us. As conservationists, we have a social license to operate. The public trusts that we are the good guys, we're doing the right thing, and we're making objective, evidence-based decisions. And the term endangered species is a popular currency. Everyone's heard the term endangered species. So what happens if there starts to be this perception that endangered species isn't actually an objective classification of extinction risks? It's just a marketing term. It's really dangerous. Right, so the third controversy is where we should focus our efforts. And this is really important because we don't have the funding to conserve everywhere. We really need to focus on the best places. So that's what the lemur conservation strategy did. They came up with this list of 30 priority sites. These are the sites indicated by the red pies. The problem is that they didn't use any systematic methods to choose these 30 sites. What they did, they gathered 60 lemur experts in a room, they had a workshop, and they said, which are the most important sites? But of course, if you're there and you work at that site there, you're going to insist that your site is one of the most important and it has to be on the list. Because if your site isn't on the list, you're not going to be able to get funding. And that's why we need to use systematic approaches. But these authors didn't, and as a result, the list they produced wasn't very good at its job. So the overall objective of the lemur conservation strategy is to conserve all lemur species. But in their list of priority sites, it only included 91% of species. You might think, oh, at 91%, that's not so bad. But actually, 11 of their 30 sites are redundant. They only contain species that are already conserved by the other sites. So some colleagues and I, we did a very rapid reanalysis, and we found that by adding the 6 sites that are represented by blue pies and replacing some of the redundant sites with the blue ones, we could increase the representation to 99% of all species without increasing the number of sites. It's still just 30 sites. So why on earth, Munungariru number F up there, it has 3 species that don't exist anywhere else. Why on earth would Mununga not get chosen in the list of priority sites? Simply because no one who works at Mununga happened to be in the room at the time. And this is why we need robust methods. And as it happens, the decisions about site prioritisation have some very robust methods. Systematic conservation planning is probably, it's one of the most technically advanced fields of conservation science. We have world experts in systematic conservation planning here in the room, and it's not, it's widely used. So why didn't these authors use it? So once we've prioritised our 30 sites, we decided where we're going to concentrate our efforts, what are we going to do there? And there are lots and lots of different conservation strategies. We could establish protected areas. We could work with local communities and empower them. We could do field research. We could invest in research infrastructure, like research stations in national parks. We could do reforestation or captive breeding. We could improve agricultural techniques so farmers don't have to rely on shifting cultivation anymore. We could promote tourism. We could invest in the next generation of young Malagasy conservation scientists and get them into the forest and give them training. All of these things would contribute positively to lemur conservation. But which are the best, which would give us the biggest bang for our buck? Unfortunately, we never found that. So in the lemur conservation strategy, having identified their 30 most important sites, they developed site-based action plans for each of those sites. But of course, they didn't use a systematic process. And the problem with that is that, if you're employed by a zoo, then you are going to insist that captive breeding is the best thing you can do. If you are a researcher, you're going to insist on doing more research. And of course, all these things would be useful, but we don't know which are going to be the best. So we need ways of systematically deciding. And these methods exist. Conservation science has come up with tools like concept modelling and theories of change. This is a concept model that some colleagues and I just published for a mangrove system in southwest Madagascar. Sorry, it's not a concept model for lemur conservation, but the idea is very simple. You have your conservation target and you identify the main threats, which you put in pink boxes. Then you think about what are the underlying drivers of those threats. And those are in the orange boxes. Now you have a model of your system, and now you understand what's causing the threats. You can identify strategic points where you can implement actions that will be addressed directly at abating the threats that your target is facing. It's very simple. There's no reason not to use it, and it prevents making bad decisions. So why did the lemur conservation strategy authors not use the best tools available for the job? So my colleagues and I, we wrote this paper, this critique of lemur conservation strategy. It got rejected everywhere because obviously who reviews it? Lemur conservationists. While we were trying to get it submitted for the third time, a couple of researchers at Cambridge, Bill Sutherland and Claire Wordley, came up with this concept of evidence complacency. They said one of the real problems we face in conservation is that conservation decision makers are not using evidence to make their decisions. And I thought, actually, the lemur planners, they did use evidence. They used expert knowledge. And the 60 people in the room making these decisions, they know more about lemurs than anybody. Their knowledge is incredibly valuable. And there's no problem using expert knowledge in the absence of more robust data. But the thing is, expert knowledge is subject to all sorts of cognitive biases and other issues, not to mention self-serving decision-making as we've highlighted. So it occurred to me that the problem is not just that decision makers are not using evidence, but they're not processing their evidence in objective, authoritative ways that can eliminate these biases and self-serving decision-making. So it's not using evidence, it's what you do with it. So we enlarged their concept from evidence complacency to decision complacency. And I feel very strongly that decision making, if we're going to make the very best decisions we can for lemur conservation or any sort of conservation, then it's imperative that our decisions are based on transparent, objective processes, not the subjective judgment of those with a vested interest in funding particular places and particular conservation actions. Oh, I'm nearly there already. Phew. I thought I was going to go way over time. So just to sum up, one of the big issues we have in conservation, which is frequently highlighted, is this researcher practitioner divide. We have all those conservation practitioners out there in tropical forests, and then we have all of us here doing conservation science in universities. And there's this complaint that we hear all the time from conservation practitioners: you guys, the scientists, are not producing the information we need to do our jobs. And it's a very real problem. What my research has highlighted is that there's another aspect of that, and that's that the practitioners and policymakers are not using the evidence and the tools that conservation science has developed to improve conservation practice. And I think, if the reason why the lemur conservation strategy made bad decisions was not that there weren't a lot of fantastic minds behind it. There were a lot of fantastic minds, but they were lemur biologists, not conservation planners. We need to get people together. We need conservation planners to work with practitioners. We need practitioners to use the very best tools that we've developed. Now, I've been really negative, and I don't mean to give the impression that I think this whole thing was just awful. The lemur conservation strategy was fantastic. They raised huge amounts of awareness for the lemur conservation crisis. They raised $7 million or something on the back of it. But it seems to me it was more like a marketing document than actually a strategic guide as to how to guide our conservation actions. And it could have been so much more. So I have huge amounts of praise for the people that did it. Without these lemur conservationists, we would have a lot fewer species of lemurs today. They're fantastic. They've done a wonderful job. But they could have done so much better had they used the best methods available to them. And that's really important because we need to maintain the credibility and trust of the public if we're going to retain our social license to operate. And we need to make the best strategic decisions if we're going to maximise our chances of conserving all lemur species. So I'd just like to thank my collaborators, Lucien Wilme, Patrick Weber, Unja Zafi Njotsima, Ian Tattersall, Adrian Murphy, Barry Ferguson, my wife, Louise Jasper, for providing all the lovely images, and all lemur conservationists everywhere. Thank you.